Now for years, the only bench vise I've had for metalworking was this little 4-inch import vise on the edge of my welding bench. But luckily, nearly 2 years ago now, one of my viewers, Bastel, who collects vises, sold me a really nice bench vise for an excellent price. As you can see from the dust, it's been a while. And since I've got a couple of weeks Christmas, New Year's vacation, I should be able to get this project done before I get back to work. Swivel base and its vise. That's a hell of a lot of mass for a 5-inch or 125mm vise. Since my current crappy bench vise is 4 inches or 100mm, and this is only 25% larger, it's never seemed that urgent to clean this up and use it. It's not in bad condition, it's never been seized or anything. Yeah, jaws open nearly 10 inches. That's easily twice what my crappy bench vise does. Nice beefy casting, and also a very solid sort of square or buttress thread. Doesn't look terribly worn either, which is nice. Guess this is just an alignment bushing for the jaws. The actual jaw mounting threads aren't that big. I think they're just M6. There's a broken off screw in this one, so that's going to be a bit of a pain to remove. Yep, M6. So how do we get this out? Pinned loosely here. So what have I got down that hole there? Does it have like a screwed in part? There's no hex in the head. I don't think there's a slot either. Okay, so it's just a taper pin by the looks of it, and I'm guessing it's driven in from the bottom. Okay, so it's not a taper pin, it's a roll pin. Pretty decent condition, I should be able to reuse that. Let's just knock out. Oh, there we go. The locking plate. I was wondering whether the nut might be brass, but it looks like it's just steel. I'll get that a bit cleaned up and inspect it again, because if it is brass I can't put it in the sodium hydroxide, which I'll use as a paint stripper. Nope, it's definitely steel. That makes it easy. Right, next up, the swiveling base assembly. The camshaft seems to lock. This seems to be a much thinner and lighter casting than the vise itself. I'm guessing this is not a Leinen part. It's probably a copy, maybe East German. It's compatible, so that's cool. We don't have any locking on there. Looks like it should have a split pin on it. This is pretty rusty, so I might have to put some penetrating oil on it and give it a bit of a break. I'll just try putting a little steel to protect the nut, because these jaws are pretty nasty serrated. A socket and an impact gun is probably off in a minute. I saw they only wanted $9 for a 36mm socket, so let's do it properly. Ooh, she's pretty tight. It was well rusted on. Next attempt, heat. Maybe add a little vibration in there. I think plan C or D or whatever I'm up to now is going to be. We soak this in here for a few days. Some drain cleaner. Stuff's pretty much pure sodium hydroxide. I'm going to be going away for a couple of days for New Year's Eve. I'll just leave this to take off the paint, and then when I get back I can use electrolysis to remove any rust that's on there. Since you need an alkali bath for electrolytic rust removal, you can do both in the same bath. The good thing about the sodium hydroxide, it breaks down both oil and paint. Alrighty, these parts have now been soaking for 4 days. Let's see what it's done to the paint. Oh yeah, that paint softened a fair bit. It's not completely softened, but it has made quite a difference. So I'll give this a quick scrub and then put in a different bucket and do electrolysis on it, because this is the most rusty part. My guess is at the end I'll probably need to do a bit of sandblasting, maybe to take the final bits of paint off, but I guess we'll see once it's been through electrolysis. This only ever had a pretty thin coat of paint, so it shouldn't be too difficult to remove. What about these other bits? How do they look? That paint's definitely a bit more resilient. Just need to soak that for a bit longer. For the electrolysis to work, I'm going to need a sacrificial, what's an anode? So a bit of old rebar I'll do there. To try out my new hacksaw. Wow, that cut quick. So what do I think of this Baco saw? Fantastic. It's the best hacksaw I've ever used. Very comfortable, nice and rigid. What a great design. If you want to get one, I'll leave a link below. If you buy through that, I get a little bit of the profits. Helps support the channel. Thanks a lot. Right, how's that looking? I've got my 4 bits of iron spaced around. This is kind of a line of sight kind of deal, so you need to have ions coming in from all directions, or going out, whichever the case may be. So my 4 bits of iron are nicely spaced. They're not touching the work piece. I cleaned off the top of those, gave them a bit of a scrub up to get a decent connection to copper wire. So they're running around, and that's going up to the positive terminal of my hacked power supply. And then from the negative, I'm going to have wire running down to the part. Oh, I forgot, this also needs to be an alkali solution. So I can keep working on the paint at the same time. Right, after a couple of minutes you can see the first bubbles are starting to rise. Those bubbles are hydrogen gas, so obviously you don't want to build up of that stuff, could get explosive. Do this in a well ventilated room and run the voltage low enough that it doesn't blast off too much hydrogen. Right, well after about 4 hours that's what the solution looks like. And the part. I didn't quite get all of the rust or the paint off at this stage, but around the outside most of it is gone. So I think it's time to have another shot at getting that nut off. There we go. Something moved. You know, I was wondering why they used a castellated nut, but without any through holes to put in a big split pin. But I'm wondering whether this might be a slightly deformed nut, where these are all crimped in slightly to give high friction locking. Because crush nuts like that are sometimes used on aircraft, but no, there is a hole in this bolt, so it does need a split pin. Don't really like bashing on the ears of cast iron, it's very easy to break sort of thing. It's obviously quite locked together. I had a bit of a chat with Bastel on Instagram about separating the two parts. Because there's a conical fit between the two of them, if I heat up the top part here, should be able to just break it free with maybe a drift through in here. So let's give that a go. Here we go. Right, these have been soaking long enough. Let's give them a rinse off and we'll see how easily the paint now wants to come off. Hey, I got a query from a viewer about the real power of the ultrasonic modules for these things. So let's hook it up through a power meter and see what it says. Well, it's a little bit less than the 240 watts they advertise, isn't it? Well, the greasy bits are soaking. Start cleaning up those steel parts. Okay, that's not the best tool for cleaning up the paint, but let's see how the greasy bits are coming along. Since the moving jaw also fit into my ultrasonic bath, I also used a concentrated sodium hydroxide solution to finish off its paint strip. The sodium hydroxide's taken off almost all of it. And the final hard to remove spots of paint, I'll knock them off with the little sandblaster. And the final hard to reach rusty bits, well, they get a bit of detailed work. Oh, that feels much better. Meal time! This has been sent over by a very generous viewer in the United States by the name of Stefano. Oh wow, I have to go through and sort those out because a couple of them have fallen out. So these are aluminium cutting end mills and double-ended ones, so I can break twice as many. Thanks a lot, Stefano. Okay, this is now finished with the paint stripper. So what does this casting look like? Well, definitely going to have to fill a few nicks and holes and build up these edges again. Now at this point, despite all evidence to the contrary, I'd convinced myself that this was a steel vise. Right, I'll just prep those two surfaces for welding, just take any corrosion off them. Now I've only ever MIG welded once in my life, but Alex, who gave me this welder, wants me to try it out, so let's do that. I don't have space for another full-size bottle of gas, and I've got an argon bottle for TIG welding. Alexander sent me one of those SodaStream CO2s, and we're going to see what happens when you try and mix your own, like 75% argon, 25% CO2. Wonder if that works. So Alexander and I were speculating that the internals only have a single gas valve, and whichever gas you have connected flows. And we're going to try out making our own mixture of gases by simply providing a flow of both argon and CO2 at the same time, with the hope that they mix inside, and it works. Wish us luck. Now I just googled gas flow for MIG, and the first number that came up was 15 to 20 litres per minute, so I'm going to believe that. Argon's got a much higher molecular mass than carbon dioxide. Let's say if I go 12 litres per minute on the argon, and if I want 25% carbon dioxide, that would be 3 litres per minute. Yeah, let's double that and go for 6 litres per minute on the CO2 plus 12 litres per minute on the argon to make 18 and see what happens. Well, the good news is I definitely get flow from the CO2 bottle with the MIG torch. So let's call that 6. Okay, well, so much for that idea. When I pull the trigger, no flow on the argon side. Bugger. Wonder what happens when you MIG weld with pure carbon dioxide. I'll go and look that up. Oh darn. I think I might have emptied the gas bottle when I went and had dinner. All seems tight, but no pressure and no gas. Yeah, so at this point I switched back to TIG to build up the scars and what I thought was the steel casting. Damn, I buggered up that second one. Okay, that's what I was afraid of. Apart from blowing a hole in that second one, there's so much carbon in this steel that it's just, the welds go hard immediately. So I'll have to whack those down with a grinder. It could be slowly dawning on me that the shitty, porous welds that go hard immediately may not be just my lack of talent, but also the parent metal. Not really sure if I'm improving anything here. Just really want to fill in the biggest of the craters, but... Well, luckily at this point, I gave up on welding and decided to just dress out the scars as well as I could with a file. Quite a bit of denting on there. Quite a nasty gouge on this end. I'm not sure if I'll get that right out. Now, I'm not going to get that last bit of that defect out of here. To do so, I'd have to take the whole surface down probably at least another millimeter, and I don't really want to take that much material off. Draw filing like this leaves a lovely surface finish, especially in this ductile iron. Right now they've got the ends and those other bits dollied up. There are a couple of casting defects I'm going to need to address. Obviously there was a dropout in the casting for the E in Leinen here. Right, it's time to have a shot at removing the broken screw from the jaw. Try and get the center on this. Oh, Wait a minute, it looked like it rotated a bit with the drill. Aha! Oh, it does come out nice and easily. Nice. Right, now next up, I need to knock down this surface. What I should have done at the start was just go over it with a mill. But now that I've tried welding it and screwed up a bit, I've got some hard spots in it. And I'm afraid if I try to mill it, I'm just going to chip out those hard spots and make an even bigger mess. So plan B is going to be the misuse of my tool and cutter grinder as a surface grinder. Let's see if we can get any halfway decent result out of it. You know, I really need to make up a new guard holder for this machine. This guard's pretty nice. The sprocket is never in the right place. So I need something that's much more quickly adjusted to, in both height and also in and out. Because sometimes you need these extensions, sometimes you don't. I think this wheel is much too wide for the power and stability of this machine. So what I'm going to do, I'll just offset this whole base a little and I'll put a big relief cut to take away most of the thickness, leaving only about 5 millimeters of wheel to do the actual grinding. I'm going to hit back here when I reach sort of halfway across, so this idea is a complete fail. Unless I could do it lengthwise. No, also not going to work. Oh well, I guess it's off to the milling machine. Well, you can certainly see the hard nuggets where I did that welding. A wee bit more to go there. There's still a mark in the middle and some damage on this side, so go down another 0.2. Well, you can see even a few light passes have chipped all those inserts. Luckily I only had 3 inserts in this cutter at the time, and they're square inserts so I can rotate them, but yeah. Well, that's as good as I'm going to get it. That damage is done, I can't undo it. At least I now do have a flat surface again. So while my daughter's just putting on the masking tape on the machine surfaces before we put on some undercoat, let's do a bit of Bondo on there, or bog as we call it in New Zealand. Guess it wasn't sealed that well before because this feels very hard. Just I might need a new can of this stuff. Wonder what the solvent is for this. Paint thinners, maybe acetone. After this, I tried it out. I tried thinning it with some acetone, and sure enough, it works quite nicely and still goes hard with the catalyst. I think this is about the worst part. Okay, well, the painting's going on. I guess I'd better make up some vice jaws. A couple of years ago, one of my viewers, Christian, here in Vienna, gave me this bit of copper, so I'll definitely make up some nice soft copper jaws for it. But I'd also like some steel hard jaws. This is just soft, mild steel, but I think I'd like to try case hardening some jaws. Whoops, the belt fell off. I adjust the shimming on the rod which pushes backwards and forwards on the gearbox inside, and also put it to stop here to hold this temporarily in the right position. Seems to be working now. Now, I've never used this power feed before, but let's try it out. The power is provided by gravity with this big bob weight here. The amount of force it transmits is adjustable by moving it in and out, with that feed being controlled by this knob. To start it feeding, all you do is, with your foot, lift it out of the stop position. Okay, I've just discovered the next half-assed model repair. This bob weight should be able to go all the way down to the bottom, but it can't because it hits on the motor mount. Yeah, whoever made up that motor mount made it way too long in this direction. Well, it just jumped out of gear again, but that's actually pretty cool. Sure beats forcing it through with your fingers. You sometimes see big sort of half-moon pusher devices for these metal cutting bandsaws. Now, having cut some steel, I realised just how useful one would be. Next up, let's try the copper one. Right, this gearbox is coming back out. But first, I want to finish this. At least I've worked out a methodology now to keep it working. That's dried. Next up, there's a little bit of spotting to do. There's just a few little defects. I don't want to go overboard. This is just a vise, you know. There's no point trying to turn it into a hot rod car. But the obvious defects, which are easy enough to repair, I'll have a shot at. And I'm glad that adding acetone has done a pretty good job of fixing my bog. It's all nice and soft and easy to use again. Right, while the paint's drying, I can start squaring up the stock for my new vice jaws. Right, what colour am I going to paint these with a top coat? Well, you don't even need to ask, do you? And again, while the paint's drying, it's back to the milling machine. And for this program, I've got 5 tools set up: spot drill, countersink, mill, and counterbore. Now the geometry I'm cutting is so simple that I didn't bother using any form of software to write the code. I've just put each of the different tools into its own subroutine. By commenting most out, I can call each subroutine individually, and once I'm happy with them, then I can take away all the comments and just run them all in one go. Right, let's get this show on the road with the first one. Let's check my offsets. Yep, that's good. That's the end of the first program, that seems fine. I'm going to slow down the speed on that a bit, it seems to be rubbing quite badly. And it's not flush, so that needs to go deeper. Right, for the last stop I need to flip it and put a counterbore on the back. So I'll just put a end stop on here. Oh, well, that's the first jaw machined. Oh, well, that's all finished. With the mill safely asleep, I can put on the last coat of paint. Oh shit. I knocked over my pot of paint. Big time. While that last coat of paint's drying, I can heat treat the steel jaws. That's it. Okay, so a while ago, after my last miserably failed attempt at heat treating, I got some of the stainless steel foil, you know, to wrap your parts so they don't get oxidized. So let's make up a little pouch for case hardening these bits. I remember years ago I tried to find some of the stainless steel foil and couldn't get any. Nowadays you can just buy it on Amazon, so that's cool. So this is my homegrown version of like caseonite powder, I guess. It's a mix of charcoal and barium carbonate. If I understand the chemistry, you need barium carbonate to help increase the amount of carbon monoxide in the hot atmosphere, because it's the carbon monoxide which diffuses the carbon into your steel. At least I think that's what my metallurgy teacher said. Now I'm not sure whether the powder needs to be packed all around each piece, but I'm guessing that this is the inside of the jaw, so it's least important if this side gets hardened. This is the outside, that definitely wants to be hardened, so I'll put inside to inside with a bit of powder in between. And some more on top. So 950 Celsius for about 4 hours should give me about 1 millimeter of depth to the hard face. So I came back after half an hour and it was just coming up on temperature. I checked again after an hour and it was still holding temperature. I checked after 2 hours and the temperature had dropped right off. So I guess my oven has lost its second heating element. I killed the first heating element a while ago by shorting it. Now this one's also dead. So that means I haven't had them in the heat treatment long enough to do the job, and I'll have to finish it with gas. I think I'm going to need to make a new oven. This one's useless. I'll just use my little Bunsen burner, that should be enough for this job. I sometimes forget just how well insulated this furnace is. That is probably hotter than it needs to be. Okay, yeah, that was probably totally over the top. Between getting them too hot and maybe using an oxidizing flame, that stainless steel pouch just completely oxidized away, leaving the parts exposed to the air, which means they also had no carbon or carburizing atmosphere. Yep, a lot of energy in that. This is probably going to look terrible. I guess I can always make new ones. After that pouch burnt away, there was no more carburizing atmosphere, so therefore the carbonite already diffused into the surface would have diffused further with the excessive temperature, and therefore there won't be much carbon left to make martensit in the surface. So the question is, are they hard? No, not terribly. I mean, definitely harder than mild steel, but this channel's #1 fan Nico was trying to get me to machine a crosshatch pattern into the jaws. Well, I guess I burnt it in. Yeah, they'll probably scrap those two, I'd say. Right, so I've bought some new mounting hardware. Unfortunately, the hardware store didn't have anything that was in black, and I really don't like the look of the zinc fasteners. So let's just take that zinc off. I'll just soak them overnight in vinegar. Hey, speaking of dissolving metal, when I was in the Air Force, there was an Air Mackie 339 Charlie jet training aircraft that had an engine failure at low level, and the plane crashed in an estuary. I don't know whether it was 12 or 24 hours later that the salvage team was on site, probably the next day. So there was at least one tide that went in. The Rolls-Royce Viper engines in that aircraft had thoriated magnesium compressor cases. I was told by one of the guys on the salvage team that you could actually hear the compressor case kind of sizzling, like as the seawater dissolved the thoriated magnesium. Right, it's now the next day. Looks like that zinc's all pretty much gone. Let's give this all a bit of a scrub with a wire brush. That looks better. Just clean all the paint out of the screw holes. Should have been a little more careful with that because I drilled straight into the tip of a screw. Guess I just need to move the whole thing over about 2 centimeters. Now, good aviation practice would be to tuck the ends of the split pins so that the next guy who puts his arm in here doesn't get cut on them, but unfortunately these ones are a bit too short. Probably should make some new ones of those, they're a bit loose. Man, this thing's a heavy beast. Well, since the roses are starting to sprout, the daffodils are already out, and the tulips are not far behind. My goal of having this all done within 2 weeks, let's call it 2 months. Well, I'm about ready to bolt this down to the table, but before I do that I better get some beauty shots of it, because I'm really happy with how it turned out, despite the various mishaps that happened during this overhaul. Let's see if I can magically get these 4 bolts to line up in my table, so maybe I don't need to pull it all apart again. Hey, if you enjoyed this video, I'd really appreciate if you'd put a link to it on your socials, because maybe someone else would like to see it as well. Thanks a lot. Okay, that swivel mechanism works nicely. It's very smooth and it locks with very little pressure. That's kind of cool. I can turn the vise kind of on its side to get it partially out of the way. So a very big thanks to Bastel for selling me this vise. I'll put a link to his channel and also down below a link to his Instagram page. And also a big thanks to Christian here in Vienna who gave me the copper. I'll put a link to his Instagram page down below as well. Thanks a lot for watching.